So this is going to be everything about integrals test review. So we're going to start off with number one. It's the integral of nothing, and the integral of nothing is simply just 0 plus k, or c in this matter. So it'd be a. Next one. So you can eliminate a lot of the options with this one really quickly. So if we take the derivative of the answer, we need to get to the square root, and the only one that gets to the square root is d, because if you take the derivative of that, you get x to the power 1/2, which is the equivalent of square root of x. And for the sine, the derivative of cosine is negative sine, so having a negative cosine will result in the derivative of sine. So d would be the answer for this one. And for 3, this is really simple. I shouldn't have to explain this, but derivative of the way I solve integrals is looking at which answer option gets me the derivative. And in this case, it'd have to be a, because when the 7 is brought down, it cancels out the 1/7, and it becomes x to the power 6. And since it's indefinite, you have to do a plus c at the end. All right? So 12 dv. So here you're going to want to be careful, because you can see in this answer option there's x, and although that's enticing, it'll have to be v because it's d of v. So the answer option here is going to be e, because the derivative of a variable is simply the number in front of it, as long as the variable doesn't have any exponents. So number 4 is going to be e. Number 5, this one was a little tricky. So it's a derivative of 1, or the integral is 1 over x squared. It looks really weird, but if you take the derivative of b, you'll get that. I could try to work it out on screen. I don't really have a pen to write with right now, so let's see if I can do that. So negative 1 over x. So for this, we can interpret this as negative x to the power of negative 1. And the derivative of this, you bring that down, it's a negative 1, it becomes positive. And then this goes down 1, so it's now positive x to the power of negative 2. And that's just 1 over x squared. All right. Is it clear when I go to the next slide? It does. Nice. Okay, so for this one, it's a little bit tricky because there's absolute value, and as you know, with absolute value, the slope changes. This is -2, so it's to the right of the y-axis, which means the slope is going to be decreasing until it hits 2, and then increasing once it hits 2. So right away, you can eliminate a couple, because here it says when x is greater than or equal to 0, and this one is when x is less than 0. And that means you're going to have to do multiple integrals. So that gets rid of a and b. And this is at positive 2. So this one over here, where it's going from negative 2, you can ignore that as well. And here, this one makes the slope negative after x equals 2, which would be wrong, because the slope is negative before x equals 2. And that's represented by answer option E. So number 6 would be E. Number 7 is where I stopped earlier, so after that I'll be doing work for all of these. But this one is pretty simple. Negative 3 to 1. We're given from negative 3 to 2, and then from here we're given from 2 to 1. And since this is reversed, we're going to need to make this negative, so it's negative 11 plus 6, which is just negative 5b. So number 8, the average value of the square root of x over the interval 0. Okay, average value stuff. I don't remember that 100%. Let me check. So the average value is simply 1 over the interval, which is 2 from 0. So we can just do 2 times the integral from 0 to 2 of the square root of x. And we know the integral of square root of x is 2 over 3x to the power of 3 over 2. And then that at 2 is 2 to the power of 3 over 2. 2 to the power of 3 is 2 times 2, which is 4, times 2, which is 8. and then square root of 8, square root of 8, and then multiply that, or yes, the way the answer key does it is a lot easier. Not answer key, the way this does it. This is recording, right? Yeah. Where's the draw? Alright, so I researched this a little bit. Shame to admit it, but so 1/2 times 2/3 x to the power of 3 over 2. X to the power of 3 over 2 is also x times the square root of x. And since it's from 0, we can ignore the first part, so it's from 2. So now it's 2 over 6 of 2 times the square root of 2, which becomes 4 square root of 2 over 6, which simplifies into 2 square root of 2 over 3. So the answer for 8 should be number C. Letter C, sorry. It's a bit late. 0 to k, 2kx minus x squared dx equals 18. Then k equals. So, okay. So for this one, you can just take antiderivative. Since k is a constant, it's not treated as a variable. And so this would be kx squared minus 1/3 x cubed equals 18. And since it's 2k, we can also substitute k in for x. So now with k substituted in, you have k times k squared minus 1/3 k cubed equals 18. K cubed minus 1/3 k cubed gets you 2/3 k cubed, which you set equal to 18. Multiply by 3 over 2, 18 times 3 is 54, and then that divided by 2 is 27. 27 equals k cubed, so then k would equal 3, so 9 should be C. Now let me check with photomath, because I'm a little bit unsure about this one, to be honest. Now let's hope photomath can solve it. Yep, k equals 3. Alright, now on to the next one. Particle's acceleration, which gives the correct function for velocity. So since acceleration is a derivative of velocity, we just need to take a simple antiderivative. Here there's no variable, but there's a constant, so v would equal 3t plus, and there's 2t, so that means we know that it's t squared. Sorry if my pluses look like my t's. Can't really help because I'm on a mouse. And we're also given an indefinite integral, so we're going to have to do plus c as well. So I think it should be a. Let me write that down, 10a. A function x e to the power x has inflection points at 0, -1, -2, 1, and none. So you can find point of inflections by taking the second derivative. So the first derivative of this would be, this is going to be product rule. So it's going to be first times the derivative of second. Derivative of e to the power x is simply e to the power x. Derivative of x is 1. So it's going to be 1 times e to the power x. And then the second derivative of that is going to be a repeat of that, I believe. Derivative of the front is simply 1 e to the power x plus x e to the power x plus e to the power x from that, because the derivative of e to the power x is e to the power x. So that's 2e to the power x plus x e to the power x. And we set this equal to 0. But unfortunately, there is no way for this to be 0. Because let's say we substituted in 0 for x. Well, let's go through all of the summations. So 0 to the power x, this would be 2 plus 0, which won't equal 0. Negative 1, this will be 2 over e minus, minus 1 over e, which just gets you 1 over e. And at power of negative 2, it gets you 2, I'm filling up the space, I'm sorry. 2 over e to the power of negative 2 minus 2 over, okay, well, gee whiz, looks like we found our answer, guys. Minus 2 e to the power of negative 2. So it looks like C is the answer for 11. The reason why I'm giggling at this is because I went through this originally and I thought it was E because I didn't look at this for more than 10 seconds. So yeah, 11 should be C. We're basically halfway through the PowerPoint now. Evaluating a definite integral. So we know the derivative of sine gets us cosine, so we know the integral is going to be sine. And here we need to find sine of pi over 3 minus sine of 0. Sine of 0 is 0, so that's negligible. Sine of pi over 3, that's this point in the unit circle, which is going to be square root of 3 over 2. So it should be C. Let's check with photomath just to make sure. I could check with my calculator, but it doesn't give it out in pretty radical form. So yeah, square root of 3 over 2. Nice. Let me write that down. If I care to edit this video, I will put the answer key at the end. 13. For which values of k, what are all values of k for which? Okay. So this one, we know the integral of x squared is 1/3 x cubed, and this is going from negative 3 to k, and it equals 0. So we know that this would be 1/3 k cubed minus 1/3 negative 3 cubed has to equal 0. Negative 3 cubed is going to be, here, let's simplify this, k cubed over 3. Sorry, that doesn't look like a cubed. I have to fix it. So negative 3 to the power of 3 is going to equal negative 27. So it's going to be negative 27 over 3 equals 0. So this leaves us with some options. So I think positive 3 is an option because positive 3 would get you positive 3 wouldn't work. It would be negative 3 because negative 3 cubed gets us negative 27, and this is a negative plus or minus a negative, which equals a plus. So it would be negative 27 over 3 plus 27 over 3, which would get you 0. And then putting in 0 will get you negative 27 over 3. So I believe negative 3 is the only answer. Let me check on the photomath. Yeah, k equals negative 3. Nice. Let me write that down. (14). Okay, if f of x equals g of x minus 5, this is the one I was looking at earlier. This is very weird. So we can simply substitute in g of x into here. So now we have the integral of 3/7 of g of x minus 5 plus g of x. That's also 2g of x minus 5, which I believe can be simplified into a. Oh, I completely missed a circle there. Give me a second to check this. Splendid nude guy. Oh my days. Splendid news, guys. Our good friend ChatGPT was able to get the same answer I did, so that's pretty relieving. I also don't know what ChatGPT got on the AP Calc exam, so What is it asking? What do I do? Okay, I believe that is the end of, oh, looks like I can't go back in a slide. So let me just go through this. Find the area of the shaded region. That's just normal integrals, displacement of the particle. Okay, so displacement is the integral of this. So s of 0 equals 5. This is basically giving our c, I'm pretty sure. So we need to take the integral of s of t. So the integral of 5x minus 3 is equal to 1/6 x to the power of 6 minus 3x, and then since it's at 0, it's equal to 5. When we put 0 into both of these, it's 0, so it'll have to be plus 5 during the first 5 seconds. So if we put it in 1 second, I'm just going to use a calculator for this to save time. It probably will be a calculator allowed. If not, then let's hope your arithmetic or algebra is very good. So let me erase this first. So you're going to want to take you want to find this when x equals 5 and when x equals 0. So 0 equals 5, so we can just ignore that. But 1/6 times 5 to the power of 6 minus 3 times 5 plus 5. Actually, I think that's 5 to the power of 6. Yeah, no, I cannot do this without a calculator. So simply put that into your calculator times 5 to the power of 6 minus 3 times 5 plus 5. Oh my goodness. I've made a horrendous mistake in that the exponent over here is 1. So the integral was completely wrong. The integral is actually 5 over 2 x squared minus 3x plus 5. Oops, let's ignore that. So yes, you can do this without a calculator. I realized this because I put 5 to the power of 6 on my calculator and I got around 15,000. And I don't think it's possible for a student to do that on a timed exam without wasting the entire time. So 5 over 2 times 5 squared minus 3 times 5 plus 5. This is 25. 25 times 5 is like what, 125? Let me just check. 125 over 2. 125 over 2 minus 15 plus 5 is 20, which is 40 over 2. 125 minus 40 is equal to 85 over 2. That should be the displacement of the particle. I don't want to check. If I'm wrong, let me know. Okay, I suppose we can do this one. So the integral of the function from 1 to x is equal to this. Let's find f of x. So it looks like we're going to take the derivative of this because taking the derivative of the integral gets you the original function. So the derivative of this would be 10x plus 7. And it looks like this is our c value, but I'm not sure that matters at all. And then f of x. Give me a minute, guys. So when plugging in x, you get this equation, and then we need to subtract that from when you plug in 1. Alright, looks like that's it, because I don't feel like finding anything else about this problem. Area versus displacement versus integral, this is pretty simple. Area under the curve is equal to distance traveled, absolute value of the area under the curve. That means like let's say we have a graph that looks like this. Let me make it a bit bigger. So you have a graph that looks like this. Absolute value of all of these added together would give you area. Now, if I took this in with its vectors in mind, this would be positive, this would be positive, this would be positive, this would be negative, this would be negative, then that would be your displacement. Displacement is directly correlated to integral. So that's that.